No, I started, but I wasn't very sure how to do, so I just stopped.
Oh, really?
Mhm.
Okay.
Do you want to
Yeah.
start now, or do you want to wait
Yeah,
a
yeah.
little more?
No, we can start. I don't think that he's gonna come. He will say
Okay.
he will have say something.
Okay.
Okay. So question 3, given the linear quadrature equation, what is the g-intercept?
I think, correct me if I'm wrong, but I think the 2 is the y-intercept, right?
Okay, let me double check on that.
Like, if we follow the formula.
Uh-huh. I wrote it so I can remember. Yeah, to
Because
so
the
the y
formula say that BO is the y-intercept,
bo, yeah, that,
and
yeah,
the BO is number 2, right?
the bo is the 2. Yeah, that's right.
Okay.
Mhm.
And then the equation, the
The
slope,
slope,
it's gonna be the 1.5, right?
the x, supposed to be the x, no?
Hmm. I think I think that B1 is the slope,
V1.
because in the formula we have y equal BO plus B1x, and then it says BO is the y-intercept, and the B1 is the slope. If you see in the Excel,
V1, okay.
uh, if you see in the Excel, it will show the slope is equal B1.
Oh, okay, okay. Got it.
So I think it's 1.5.
Yeah, you're right. V1 is 1.5. Oh, the slope is 1.5, the slope. Okay.
Okay, now he wants to know the value of x when, oh, I mean, the value of y when
So
x
we
is equal 16. So we just need to do the
subtract,
equation.
I mean,
Minus
substitute
3
x
plus.
by 16.
Yeah, I think we need to do minus 3
You really want?
plus 0.25 multiplying 16.
So I got a
Is it
1.
right?
Yeah.
Yeah, I got one. But I don't remember, like, he talked something about scale. I don't know if we put the 16 the scale, but here he's not specifying, so I think it's 16, right?
Mhm. Yeah, it will be only
Okay.
16.
Okay, for the next 7 questions, use data. Be sure to use confidence data for explanatory variable discard. Okay. Make a scatter plot of the math efficacious data of the three data shapes introduced in the reading. Which shape best describes these data? Okay, mine.
I'm
Uh,
gonna open
kind of
the
looks. I don't remember this part of the reading, but looking to my shape, it kind of looks like a banana, but
okay,
I don't know.
I'm gonna put insert the information on the Excel sheet to see
Okay.
what I get.
You wanna put the keys with here, please? I have nothing, no swimsuit. I need to shave.
I need to change our freaking wolf. Okay. That would be cool.
I'm put it in the copy paste.
No rush.
Is this annoying for you?
Go get ready, cause you take forever.
So I would say it's more like a hot dog for me. I can share my screen because a banana I think would be like more like a curve, and this one looks
That's true. Can I
more
see
like
your
straight.
screen just to
Yeah.
see if we got the same?
Yeah, let me screen share. Okay. So this is my,
Yeah, I got the same thing.
because it doesn't curve on the sides, so I
Mm-hmm.
think it's more like a hot dog.
Okay, because I don't remember reading anything about it. Do you remember?
Yeah, yeah. Yeah,
Oh, okay.
that's why, like I'm saying, like banana looks like a curve at the end, like a banana. So
Okay. So based on the shape of this scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model this data? Simple linear regression is appropriate for this data. If simple linear regression is used for this data, it's not appropriate for this data. Let me find.
so I think that is the first one. Simple linear regression is appropriate for this data.
I also don't remember about this, but I believe you. Why is it appropriated? Sorry for asking.
So in the book, textbook, it says that the type, if it's a linear, the hot dog is a linear pattern.
Mm.
And this is the decision that, when that happens, it says conduct regression analysis to determine if there is a significant linear relationship.
Got
When
it.
the hamburger is, the decision is linear regression is not appropriate. And when it has and the banana, it says linear regression is not appropriate. So only for the hot
So
dog.
the hamburger and the banana are not appropriate.
Only the hot dog, and we got the hot dog.
Okay.
Mhm. Okay, so the first one. How many observations are in the data? I'm supposed to find it from here.
I don't remember also about the observations part.
I'm thinking it's gonna be X if it's 6, or if it's the total of that we copy and paste, like the 141. You know how you copy and paste into your
Which one?
the first two columns, the data that we got from the Excel is 141. So I'm thinking that's the number.
Like that would be the sample size, right?
That's
It.
what I'm wondering, if that's what it means.
Uh-huh.
Let me check my notes to see if I find something about the observation data.
Okay. I only look in my info.
I would say 141.
Yeah, that would be my guess as well.
Yeah, I don't see it. I don't wrote any notes about the specific definition of that.
So the y-intercept, I got 1.296.
Let's see. Try. Oh, it's running there. y-intercept 1.296, yeah.
Yeah, okay. Slope, I got 0.0.
The slope point 0.042.
What did you get?
0.042.
0.042.
Yeah.
Okay, now we need to do the equation.
I give it to X. Okay, so 0.042 to 16, no 4.
Don't forget to multiply per 4 because it's the x. I got 1.464.
Plus 1.464.
Yes.
Yeah, that's what I got.
Okay. The confidence data results from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Round to do this. Hint, because there's a positive correlation, we can use the largest x value to find the largest predicted value of f. Okay.
The confidence
That's for each question scale to 6. That's hard. I am not very sure how to do that.
is it so the value of x so I'm like looking at the response variable x, in the Excel sheet. So I'm guessing that we have just to look at the highest value, and right now it's like 5 something. So I know. Do you see in the Excel sheet the one that we got the results from?
Yes.
So,
are you trying to look for the biggest value?
Yeah. Yeah, I can
Okay, there's
593 so far at the beginning.
Yeah, I think that's the biggest. There's a 6.
Okay. I'm still going down. You see a 6? I didn't see a 6. What arrow?
There are
Go
2
low.
6s.
Oh, really? Huh.
Mm-hmm.
I don't see any.
Yeah, I think it's 6. There's a 6 in the 110. There's another 6 in the 82.
I didn't see 82. So yeah, I think it would be that.
The positive correlation is large as 6.
I'll put down. And it also it says, the scale from 1 to 6. It's 6.
Yes.
Right.
Let's try, because I honestly have no idea how to do it.
Yeah, me neither.
How many? Oh, sorry. Go ahead.
Explanatory independent variables are present in simple linear regression.
Simple
So-
linear regression. Dude, I usually have all the notes.
How many explanatory independent? I'll say more than one. I'm thinking that now it's in the third column. I mean, in the third column, it's the same. The first column, I mean.
So just like I'm taking a look in my
independent. I want to say more than two.
Just a second, I'm taking a look in my notes. Yeah, I think it has to be more than two because it needs at least an X and a Y, right?
I think yeah.
Or two. I think it's two.
Why two?
Because it has an X and then it has an Y.
Well, the independent is X. So it's asking for how many explanatory independent variables. So the independent is the X and the dependent is the Y.
Because it has
more than two.
More than two?
Yeah.
Okay, let's go with that.
Maybe which one it was right? Maybe neither.
How many response? Oh, okay. Wait. The independent one is, which one is the independent one?
The Y.
The Y is the response one.
The dependable. Yeah, response variable is the dependable. And explanatory variable X is the independable.
Independent?
Independent, I mean.
Because if you look in the Excel, it says the response variable is Y and the explanatory variable it's X.
Yeah. And like what independable is the explanatory variable X and the dependable is the response variable X. I mean Y. Response variable Y.
Okay, let me just write this down. Response X. So wouldn't be just one for each? Because it's just one, it's just X or just Y. Wouldn't be just one?
You know what? It has to be two. It has to be two to make a point. Or no, yeah, it has to be one of each one. So yeah, it would be only one. Duh.
Yeah, I think it's one for each.
Yeah, it takes one for each. You're right.
Okay.
You only need one to make one of each.
Okay. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include the hat size, circumference of the hat, and lengths of the major and minor axes. Meaning, a company wants to predict the size of hat given the circumference. What is the response variable?
Okay, so the circumference Okay, so response variable. So
I think it's the size of a hat because the circumference is being predicted. So I think I would say the third one.
Yeah. Wait.
Okay, so
no,
that's it.
I mean, the company was built the size of the hat given the circumference. So what is the response variable?
Because it reminds me from the example he gave that to measure the size, like the length of the body of the crocodile, they had to measure the length of the head. It was something like that.
Oh, okay, let me just give this a tap for a minute. So, okay, so if we, okay, so we wanna predicting body length of a crocodile using his leg. So we wanna know the length of the crocodile using the head. So the explanatory variable is the head, and the response variable is the, yeah, so the hat size, you said. Hat size. Okay, yeah.
The third one?
The hat. Yeah, that's the one, you're right. Just want to make sure that I was, understanding it too.
Okay.
Okay, I think
Let's
submit it.
submit. Hmm. Oh, we got number 8, number 9, number 10, number 11 wrong.
Oh my gosh, it's horrible.
And number 15.
What happened here?
Do very well this one. We can figure it out by ourselves later, or do you want to try it again?
No, we can try ourselves later. That's fine.
Okay.
Maybe we could have to invert
Okay.
the data,
Yeah, like one that I'm not very sure is the observations one.
Yeah.
Makes so much sense. I don't know why we got the slope in the y-intercepted in the 9 and in 10 wrong as well.
I
Seriously.
think that is because we have to reverse the data. I'm gonna reverse it and put, whatever we get.
Okay, sounds good.
Okay, well,
Julia,
participating.
I'll see you.